Good morning, ladies and gentlemen. Thank you guys for being here, taking your time out of your day. Let's go on ahead and get this presentation started. So go ahead and start.
Okay, good morning, everyone. We'd like to introduce you to our smart farming system. And so the smart farming system took a lot of, you know, teamwork, dedication from the team. And so Kareem here, he's a SPC, U.S. Army National Guard serviceman. And so thank you for your service, Kareem. And he's also a full-time student. I'm a 30-year veteran as well from Sandy National Laboratories. I had to take a medical leave, and it was one of the reasons why uh, I have a passion and where I drum up the idea for a smart farming system. Um, so, what is a smart farming system? And so, this provides an array of resources for real-time environmental stats on the physical security of a crop and also of the plant health for yield. One of the main drivers and purposes came about because of my real life experiences during New Mexico's first hemp farming season in 2019. Um, a lot of the farmers went in really excited about a new industry because the hemp legalization had just come in under the 2019 Farm Bill in 2018. And unfortunately, though, the farmers didn't have a lot of input from the USDA. And so
Sorry, they're having trouble hearing you.
are they having, okay, so then I'm gonna go ahead and remove my handy dandy mask here. And so hemp legalization occurred in 2018, actually, in December 22nd. And unfortunately, though, the farmers didn't have any guidance from the USDA until March of this year. And one of the problems that they faced was pest control because they didn't have any approved pesticides. And so one of the factors that I wanted to cover in the smart farming system was to help farmers with a environmentally safe pest control system. And so this system has the ability to push out ultrasonic high frequency sound waves that deters pests. And so it's environmentally friendly. There's no carbon footprint. There's no toxins in your plants being sprayed. And it's actually rather easy. And the other problem that they came across was um, a lot of the farmers didn't know a lot of information about hemp. And so one of the things that they ran across was not realizing that when um, they invested in this really high top dollar feminized seed, and which was supposed to give them a lot of female plants so that they have very high yield so that they could have a lot of CBD. And unfortunately, there were a couple of roosters in their coop, so to speak. And so the flowering hemp plants were pollinated, which triggered the plants to stop producing flower and trichomes, which hold CBD, and started seed propagation. And so farmers, their plants, so to speak, their yield dropped, significantly dropped. Another problem that they faced was they they didn't necessarily know what they were growing, how to collect their yield. And so another issue that they came across during their grow season was theft. There's a lot of people driving by their fields saying, hey, look. And so they needed some kind of security, which was also a requirement of their licensing. They had to have security. So this system also helps not only do the pest control and the pollen control, which was a detector to let the farmers know when there's high pollen in the area so that they could go out to the field and try and find the male plants before they pollinated their flowers. And so with the security system, which was also part of the pest control system, same system running at the same time, was able to deter, any type of theft and also help them establish good requirements with the state of New Mexico. This system also provided them with a weather station, because one of the other issues was a lot of the plants went into stress because they were either too dry or too wet. And when hemp gets stressed, it spikes their THC levels, which would then cause the farmer problems, because then it will increase their THC yield, which would automatically put them in a hot status, and they would have to then destroy the whole crop. And so there were a lot of issues that happened with the first hemp grow season, and that is still happening these days. And so the acreage of hemp grown the first year compared to now has dropped threefold. And so it's a real indicator of the agricultural system needing assistance in this department, especially now that more farmers are going to want to plant, because New Mexico just passed legalization for recreational cannabis. And so I want to go ahead and turn it over to Kareem, who's going to go over the pest control and how it works in the system.
Okay, well, so on the screen, you'll see that we're going to be talking about the smart farming systems, functions, and solutions. This is just all the problems that she enumerated prior. We're going to talk about how we solved those and went about it. Starting with the pest control. On the top inside of our robot's head here, he's just got a ultrasonic sensor, which, like she was saying prior, pulses out a certain frequency that pests don't like. So obviously it's cost effective, environmentally friendly. You don't have to worry about it impacting any other crops in any type of pesticide way. We also have pollen monitoring, which is done by a growth particle sensor. You'll see a lot of these inside of the video that we ended up coming up with. We get into a lot better detail of those devices than that one. It's just capable of detecting particles. And hemp pollen is pretty large, so it's easy for it to detect, which is very critical for our system and all in all. We also have a GPS system too, which was a big problem for everybody who used that in the room. Essentially, we were all trying to brainstorm about how to get it working and how to get it going. There are some descriptions about the particular model that we used on the screen here. It's capable to run with 3 to 5 volt power. We have it going off of 5 right here. There's an LED indicator. If you look on the screen, you'll see my little mouse right there, right around here, I believe. And that LED indicator blinks blue. That's how you know it's collected data and it's ready to push data. So yeah, we'll move on a little bit more from that. That was all kind of a part of the pest control. So it'll pulse out, tell us where things are with the GPS and how to get that going. Another function for that ultrasonic component was the security system. So while it's pulsing out, it goes about 13 feet. The max is about 26, but we set it to about 13. It'll give real-time notification. So if it's pulsing out to 13 feet, it knows about the time in which those pulses are going to be read back in. So if it's pulsing out 13 feet and say it takes like 0.5 milliseconds, but it's coming back at 0.25, obviously there's somebody there or something that it's hitting where it's not going the full 13 feet to come back. That one is, we'll talk more about that on the video actually. Let's kind of just run through this. Like she mentioned earlier as well, there's a weather station. We have that hooked up to our Adafruit IO dashboard. You'll see it on the screen. It's a little bit different from the video because this was, we kind of updated a little bit through a little bit of things that we wanted to on there. You'll see on the video that we do have a OLED display. that just displays like mainly just the GPS, the latitude, the longitude, altitude, and the number of satellites that we have. All of this, the whole system is sending out the same data along Wi-Fi or via Wi-Fi. And that's where it's populating on the Adafruit. Right here's a little link to it, if you want to look at it later. For the weather station, in bold letters from here on, you'll see that they're kind of black and bold. Those are the components that we have that we'll be talking about. The one in front of you on the screen is the soil sensor. That's just measuring the soil in the ground to populate it onto the dashboard right here in this upper left one, the moisture of the soil. You can see we have that in percentage values. So moving to the BME, this is all part of the weather station, by the way, kind of gathering all of that. The BME 280 or BMP 280, this one's gathering humidity, barometric pressure, and temperature. It's gathering it on this little sensor right here, little square right here on the upper left portion. And we're gathering that data and as well sending it up to the Adafruit IO dashboard. Some side components that we use is the solar cell. You'll see that on the top here, if I can pop this out. So there's a stake there. I don't know if we get it too good in the video. You stab that into the ground, the boy just stands. But kind of hold this right here. You'll see right here where my finger is tapping is our solar cell. That's where we've mounted it to where it'll gather, where it'll recharge itself in the inside rechargeable battery for the system. That one, the one underneath that is the stepper motor. Sorry about that. That one's mounted right underneath the head. It's this little gray box that I'm tapping on the screen. I don't know if you guys can see that too well, but you'll see it in the video. So let's not get too deep into that one. That one's running on 5 volts. That's what we have it connected to. It's got some insulation on it so that it can't really overheat because it's obviously rotating, creating friction. We have that going on about a 180 like axis so that it's constantly rotating back and forth. That works with the pest control. If in this region it's sending out frequencies, as well as the security system, same thing within this region, it's detecting whether or not somebody's there. To the right of that, or to the left of that, I guess from my perspective, is the little OLED, so it's a little black square right here. That's, like I said prior, just displaying satellites, latitude, longitude. It's an I2C component. And that can work from 3.3 to 5 volts as well. Right now we have it running on 5. And so this is the laser cut enclosure, and this is about some stuff you want to talk about.
Sure. And so we were trying to decide on what type of enclosure we wanted our little Bob bot to use, since the ultrasonic sensor, it looks like 2 little eyes. And one of our classmates, she made a little 3D printed face. And so Carly, thank you so much for your contribution, your gift for our Bob's personality. And so we decided that we were going to go along with a wooden enclosure, primarily because of the living hinge. And I want to thank Wesley for the idea of the living hinge. It was a great way for us to have the dust sensor enclosed and protected from the elements, and yet still breathable and have access to the particle sensor, or to the particles and the pollen in the area. And so what I did is we found an enclosure that we liked, and we found the file for the living hinge. And so I spent a good 2 days trying to incorporate the two. And I'm I'm still learning Adobe Illustrator for the STL, well, not the STL, but for the engraver. And I just couldn't get them. So when I was researching and trying to find something else, I stumbled across a really cool website that had all this all put together. And so we were able to finally put together the actual box that we wanted to use. And in addition to that, I also engraved on there several different items on the sides to identify all the different component capabilities.
And on the screen right here, you'll just see some pictures. We're wrapping up kind of with the PowerPoint portion of our presentation. So there's just some pictures. I don't know if you guys saw the prior one. I'm not that important, so it's not going to be on the screen. So there's that one. And so right here we have the video demo. Like I was talking about prior mentioning it. We'll just run that real quick.
Hello, this is Bob the bot. He is a smart farming system. He has a security system, a pest control system, and a weather system. He has built under here, he has a soil moisture sensor that measures the soil moisture levels so that we can have healthy plants. Over here we have a display unit that shows his GPS coordinates, and he has a rechargeable battery, and we have a solar cell right here that helps him recharge. He is in a wooden enclosure. We used a laser cutter to make a living hinge, and we also were able to engrave different things. We're with the deep dive group, and we are very happy that this boot camp has showed us so many things, and we'll be getting into more of the components. And so I'm going to demonstrate something right now where we're going to be putting some baby powder into this, because he's also a pollen sensor, and farmers are very interested as to when their flowers are getting pollinated, where their fruit is getting pollinated. And so I'm going to turn over to Bob here. His eyes are essentially an ultrasonic sensor system that is used to send out pulses for pest control. Pests don't like a certain frequency of sound, and so when he emits this ultrasonic sound, it deters pests from the crop. His eyes are also a security system, and so whenever a intruder gets into his line of sight, he triggers off this red security system right here. That button, it's usually green, so now it's red, saying that he has detected an intruder. And when that light goes red, or that circle goes red, the farmer is sent a text message indicating that there's an intruder. So now what I'm going to do is I'm going to hand it over to Kareem, and he is going to talk to you about Bob's insights and how he actually runs and how he detects all these fun, wonderful things.
So when you're looking on the inside, you'll see that she was talking prior about the pollination thing, right? There's a little baby powder right there for it. So on the inside, you'll see that we've got our particle argon going. We've got our BME, that's gathering atmospheric conditions. We've got our MPU, which is an accelerator or accelerometer. That's gathering the acceleration on 3 different planes. We've got our GPS, which is feeding the data over to our OLED and to our Adafruit dashboard. This device, when you see all these lights going, you'll see a little blue light blinking, a red light blinking. Those are all good indicators that the system is working as a whole. And when you do that, we'll bring you over here to look at the dashboard. You'll see that it's starting to pick up a little bit of the pollen in the region right here. You look up, this is the moisture of the soil, and the satellite count, currently we're connected to 0, and the moisture is none because it's just in a metal tube. To the right of that, you'll see a street map of Albuquerque, right? That's because that's where we're located, Albuquerque, New Mexico, and we're located where those blue dots are in particular. And at the very bottom, underneath the circle indicators in which she was talking about, you'll see our BME 280 data feed, which is drawing this data. All right. So yeah, that's about our video demo. Moving on, there's some developmental challenges that we had. Some was problem solving. We were having a little bit of trouble figuring out what we were going to put the thing on. The GPS, like I had mentioned, There was just all, it seemed like a different day, new problem type of deal. We had some teaming solutions that came up with those that we helped solve together. Um, so it was great communicating with each other in a way that we could understand and learning how to communicate well. Um, some future goals for this project would be to have a camera on it. Obviously, it kind of would benefit the security system portion of it, and random frequency outputs. And those would come from the piezoelectric elements that we wanted to add as well. But those had like a dual function, one of them having security and frequency changes, because the piezo would be able to change the frequencies, as well as be able to measure vibration inside of like the collection trucks. If they're taking yield or crops somewheres, we would know if they're dropping or mishandling any of the crops or the product for that matter. We'd also want more efficient models, right? I mean, this is cool and all, but you know, it's kind of bulky, you know. Just think it'd be cool to have that, and with that comes more efficient components. A lot of the stuff that we have could be better with better components, and obviously cost cheaper. If we could find cheaper components that just do the same thing, it only makes sense. We'd also want geo mapping for rapid location of high pollen areas. It's easy to just pinpoint the location of the GPS now, but with more of them, we'd probably be able to pinpoint exactly where said pollen areas are, which would help the farmer find male plants. So this is the last slide for us. It's just got our information here. Does anybody have any questions for us?